Welcome back to another video, and in this video we're going to somewhere that was something that we learned in the previous few videos, right? And that would be called limits. Now, as we recall, with limits, they have the notation of lim, right? Now, the notation for it, remember how it was lim, the limit, as x is approaching some kind of value of f of x is equal to L, right? Now, take a look at this example problem. As the limit as x is approaching 3 of x squared minus 9 over x minus 3. Try solving this out. Now, hopefully you just took a moment to solve it out as our little do now for today. And it comes out to become 0 over 0, right? Because whenever you plug in 3 onto the numerator, 3 squared equals, it's just that 9. And then subtract the 9, which is 0. And then the 3 minus the 3 on the denominator is just 0 as well, right? So this is what we call the indeterminate form. Indeterminate form of 0 over 0. Now, hopefully you recall this whole entire statement here, right? So now we have to figure out what can we do to this equation, well, to this function, so that we can actually make it come out as the limit that we want it to have, right? So then what we would usually do is factoring, right? So the factors of x squared minus 9 is just x plus 3 times x minus 3. So x plus 3 times the x minus 3 over x minus 3 at the bottom. Now, the x minus 3 cancels out on the top and bottom, which leads you to the limit as x is approaching 3 of x plus 3. And our answer leads us to 6. Now, this is just like a little basis of an example, right? And the next example that we're going to do won't be that easy anymore. So in this example, it is the limit as x is approaching infinity of 4x over e to the x. Now, how would we solve this limit? Now, once we start solving it, right, as, let's say the function 4x, right, as it's approaching infinity, of course, it's going to go to infinity as well. So, in this case, it's the same thing with e to the x. In this case, we have something as like a new indeterminate form, right? We have something about infinity over infinity. Now, how do we actually find this limit, right? So, something that we use is something called L'Hopital's rule, okay? So, we're gonna come back to this example later on, but now we're gonna go here. So, this is what we have, L'Hopital's rule. Now, remember, this is pronounced as L'Hopital. It's not La Hospital, it's not anything like that. Right? And this is made by the French mathematician L'Hopital, right? And he was from the 17th century. Even though it was like named after him, but most of the work was done by Bernoulli, right? And most of the credit was given to Bernoulli's brothers and the whole entire family that they have, right? And just because it was in the 17th century, right, they figured out how to deal with the indeterminate forms of 0 over 0 and also positive or negative infinity over infinity. So first off, let's write like a basis rule here. So this rule can only be applied to the limit, right, as x is approaching, let's say, any value a of f of x over g of x, and that could be also equal to positive or negative infinity over positive or negative infinity. Or it can be applied whenever the limit as x is approaching a, which is our little value there, of f of x over g of x is equal to 0 over 0. Now, the main reason why I'm teaching this after we taught derivatives is because it has to deal with something with derivatives, right? So just because these are the case, right? The case of point is these two statements here, right? Now, what we can say is that the limit as x is approaching a of f of x over g of x is equal to the limit as x is approaching a of f prime of x over g prime of x. So basically, you're just taking the derivative of the numerator and you're taking the denominator of the you're taking the derivative of the denominator, just so that we can find the limit again, right? And of course, let's say that you do the derivative, but then it still comes out to be like 0 over 0, or positive infinity over positive infinity, or just negative infinity over negative infinity. And you can do it again, right? You can do it twice, you can do it 3 times, right? But at the end, whatever answer that you lead to is going to be what the limit is equal to. Now, this is what we call L'Hopital's rule, okay? Now, this is an alternative method for calculating these indeterminate limits, right? Previously, we had to deal with factoring, we had to deal with conjugates, right? That was because we didn't go over derivatives yet. So now, since we went over derivatives, we can talk about what L'Hopital's rule is. But case of point, right? For some functions, right? It uses L'Hopital uses the derivative to find the limits of each form, right? But in some cases, right, sometimes you still have to figure it out by using like quotient rule and all those other kind of rules that we have for derivatives. So now, since our first example was this, our first example was the limit as x is approaching 3 of x squared minus 9 over x minus 3, right? We all know, hey, it's going to be equal to 6, right? Because in the beginning, as our little do now, we solved that as equal to 6, right over here, right? And now, let's try using L'Hopital's rule to figure this out. So take a moment, pause the video here, and see if you can figure this out. Alright, so hopefully you just took a moment and tried to figure this out. And this is what we would do. On any AP test, we must say that it is in the indeterminate form of whatever it is. So like 0 over 0, right? So now this is how I would write it. So just because we have the quotient inside of the limit, right? We're dividing two things. We can write it simply like this. So the limit as x is approaching 3 of x squared minus 9 is equal to 0. And then on the bottom there, we're going to write the limit as x is approaching 3 of x minus 3 equal to 0. We're going to do the curly brackets here, and we're going to write indeterminate form of 0 over 0. Now, this is where we declare that, hey, our answer is going to be 0 to 0, so we must use a different way to figure this limit out, right? Declaring 0 over 0. So now we can continue on to our next step, right? Now, in the previous attempt that we did this example with was just using factoring, right? So now in this case, we're going to try using L'Hopital's rule. So we're going to take the derivative of the numerator, and we're going to take the derivative of the denominator, right? So now, let's try this out. The limit as x is approaching 3 of the derivative of x squared minus 9. That is just 2x, right? Using power rule, and also whenever we take the derivative of a constant, it equals to 0. So the negative 9 just becomes 0, and then the x squared, it becomes 2x because of the power rule. Now, over, we still know that, hey, whenever we have a constant and we take the derivative of that constant, it's going to equal to 0. So we only need to take the derivative of x, and any x value that we have, any variable that we have, and we take the derivative of, it's just going to turn into 1. So we can write this 1 down here, right? Remember, we're taking these separately. We're not using the quotient rule for this, okay? So now we can write this as the limit as x approaching 3 of 2x, and when we substitute it in, right, it would become 6. And referring back to our original answer that we got when we did factoring, right, all the way up here, where we still got the 6 here. So then we're good with this, right? We both got the same answer here, and both of the answers are just 6. So now, let's take a look at a different example. This time, we will be looking at the example that we said that was equal to positive infinity over positive infinity. So as we recall that, it was the limit as x is approaching infinity of 4x over e to the x. Take a moment and pause the video here and see if you can try to figure this out. Okay, hopefully you just took the moment there and tried to figure this out, right? So let's try to do this together now. So remember, we always have to declare that it's in some kind of form, right? In order for us to do L'Hopital's rule. So let's do the limit as x is approaching infinity of 4x, that's equal to infinity, right? Because our graph is moving upwards into infinity. And the limit as x is approaching infinity of e to the x, that's also equal to infinity, right? So now, what we can say that it's the indeterminate form of infinity over infinity. Now, these are some really ugly infinities. And once we do that, now we can apply L'Hopital's rule. So let's start applying L'Hopital's rule. Now, the derivative of 4x is just equal to 4, right? And then the derivative of e to the x is just e to the x because it stays the same. So in this case, right, now we can start substituting the positive infinity, right? So just because let's say the function was 4, right? Y equals 4. So as it's approaching infinity, as x is approaching infinity, it's still going to stay as 4. So we're going to keep it 4. And then over, whenever e to the x is to infinity, we're still going to get infinity, right? So we're going to write infinity on the bottom. Now, you might ask me, what does this equal to eventually, right? Well, this is what it equals to. It equals to 0, right? So now 0 is our answer here, right? Now, because the whole point is because on the top you have a constant, right? So even if you did the L'Hopital's rule again, right, you're still going to get 0 over infinity, which is just 0 because it's in the numerator. So it's safe to say that whenever we have a constant, like any number above infinity in like a fraction form, just like what we have here, where the 4 is on the top, right, and then we have infinity on the bottom, right, that is always going to equal to 0. So in this case, 0 is our answer. Now remember how I mentioned that sometimes we have to do L'Hopital's rule twice, right? So as we try to expand what we have already, so the original rule for L'Hopital was this. The limit as x is approaching a of f of x over g of x is equal to the limit as x is approaching a of f prime of x over g prime of x. Now, tell me this. What if we had to do it a second time? We have to apply L'Hopital's rule a second time, right? So, this is what we would do. It'll be equal to the limit as x is approaching a of f double prime of x over g double prime of x, right? Now, remember how we spoke about these double primes here? In our previous calculus video, we said that those were higher order derivatives. Now, those are derivatives after derivatives, right? And this is, remember, this is just an extension of the rule that we have. So we can have the third derivative, right? We can have the fourth derivative, any type of form, depending on how long it takes for you to solve out the whole entire problem, right? So let's do an example. Our example here is the limit as x is approaching infinity of e to the x over x squared. Now take a moment and pause the video here and see if you can figure this out. Okay, so here, we're gonna try figuring this out together now. So by using L'Hopital's rule, right, we have to say that it has the indeterminate form, right? So let's do this. The limit as x is approaching infinity of e of x is just equal to infinity, right? And then the limit as x is approaching infinity of x squared is also infinity. So we can say in this case, indeterminate form of infinity over infinity. Now, just because we just did this step, right, we're going to take the L'Hopital's rule now, right? So we're going to take the derivative of the top and bottom. So the limit as x is approaching infinity, and the derivative of e of x, here, our top part, is just equal to e of x. So we're just going to write e of x on the top. Now, our derivative of, we're going to use a different color now. Our derivative of x squared here, it's just 2x, right? So now, let's try solving this out. E to the x, right, as x is approaching infinity, e to the x is also approaching infinity. Now for 2 times x, right, 2x, as x is approaching infinity, 2x is also approaching infinity. So we have another indeterminate form again, right? So we're going to write the limit as x is approaching infinity. The limit as x is approaching infinity of e to the x is equal to infinity. And then the limit as x is approaching infinity of 2x is equal to infinity as well. And now that is another indeterminate form of infinity over infinity. So now we have to take it for the second time and hope that we can actually achieve some better results. So now the limit as x is approaching infinity, right? Now the derivative of e of x is still e of x. So we're going to write that on the top. And now the derivative of 2x, what is that? The derivative of 2x is just 2. So 2 as a denominator, right? And of course, once we solve this for infinity, right? As e of x is approaching infinity, well, as x is approaching infinity for the function e of x, e to the x power, then e to the x power is also approaching infinity. So our answer in this case is just equal to infinity, right? So that's the whole point of how this works, right? Remember though, this rule will only apply if it is a function over another function, right? And it will only apply if when you do substitution, it's going to result as 0 over 0, positive infinity over positive infinity, or negative infinity over negative infinity. Okay, this does not apply to other limits that you have. So let's say if there was like a conjugate, right? Then you have to use a conjugate, right? It does not apply to any other limits except for the ones that we're doing right now. So just because we just did that, right? We're going to do one last example here. And that one last example, right, is this. Evaluate the following limit. So the limit is the limit as x is approaching 2 of x squared minus 4 over x plus 2. Pause the video here and see if you can figure this out. Now hopefully you just pause the video here and try to figure this out. And let's try figuring this out here. So we're going to do direct substitution, right? Now on the numerator, 2 to the 4th power minus 4, that's just 0, right? 2 to the 2nd power minus 4. And then on the bottom, it's just 2 plus 2. And we get 0 over 4, which is equal to 0, right? So this is where some people mess up on. Some people mess up on this. They're like, oh, I see that we have a function on the top, and then we have a function on the bottom. So we must use L'Hopital's rule. No. Remember, L'Hopital's rule only apply whenever you have 0 over 0, right? So this is the sole purpose, or the sole reason why I've emphasized telling you to write the indeterminate form of infinity over infinity, or just 0 over 0, because that will tell you, oh, should we use L'Hopital's rule, or should we not use L'Hopital's rule, right? And once you get into more advanced mathematics, right, you're gonna do these limits really quickly, right? So for me, I look at this function and I see, oh, the denominator is just x plus 2, right? And the limit is when x is approaching 2. So 2 plus 2 equals 4. So we can't use the L'Hopital's rule here, right? So on the tests, they will try to trick you with these kind of problems, right? And they're trying to see if you fully understand the topic or not. So if you use L'Hopital's rule on this specific problem example that we have here, you will get a totally, completely different answer than what you would want to get, right? Instead, you will get some random you might even get like some random number, right? So you must use L'Hopital's rule when it's supposed to be used. So make sure that you don't mess that up, right? And of course, as an overview and like an overcast of what we just talked about today, we talked about L'Hopital's rule and how it connects to limits. And also we talked about how derivatives work with these limits. So now the key points here is that L'Hopital's rule can only be used whenever the substitution is equal to 0 over 0, positive infinity, or negative infinity over negative infinity, right? So we're going to write this down here. It's going to be our major takeaways. Major takeaways. Only use L'Hopital's rule when the substitution of a limit results in 0 over 0, positive infinity over positive infinity, or negative infinity over negative infinity. And secondly, only take the derivative of the numerator and denominator. Now, some kids, they also mess up on is that they take the derivative of the whole entire function. So they're using the quotient rule for it, right? No, do not use the quotient rule for this, right? The whole point here is that you're taking the derivative of the numerator and you're taking the derivative of the denominator. So they're both separately. They're both taken separately. Do not mix and match here. And that is it for this video because we've covered all of L'Hopital's rule and hopefully you do some more practice on it because this rule is very important when it comes to solving these complex limits that you have here. So always remember to keep on practicing and I'll see you guys in the next video.